You're welcome. All right, so now we're going to be looking at light, okay, in this part of the tutorial. So we actually discussed sound wave. So in this tutorial, we're going to be looking at light. All right, so now what is light? Now, light is a type of wave that stimulates the sensation of vision. All right, and of course, uh, before vision, okay, is possible, and of course every object can only be seen if only the light of that object reflects to the eye, okay, and that is why you cannot see an object without light, right? So object is seen because the light from the object reflects, and of course the image is being formed at the retina of the eye. So please take note of that. So we looked at the sources of light, okay. Now, for sources of light, we have two types of objects: luminous object and of course non-luminous object. Now, luminous object is so called why? Because they are objects that produce their own light, okay. For example, the sun produces its own light, all right, but earth is a non-luminous object. Why? Because it doesn't produce its own light. The light that you see, okay, on the earth is reflected from the sun, and that is why we have day and night, okay, because as the earth rotates, it is only the part that is facing the sun that receives light, okay, and that will be the day. But as it actually faces away, turn away from the sun, it becomes dark. That's how we have night, right? So please take note of that. Now we talk about the transmission of light. Light can be transmitted through the following object. We have the transparent object, we have the opaque object, okay. Light can pass through opaque objects. Now of course we also have the translucent. Right, so now for a transparent object, you know what that means already. These are objects, okay, one can actually see through, and of course you can allow light to pass through it. Light can pass through it, okay. Light can pass through a transparent object and you can see through a transparent object. Opaque, okay, light cannot pass through an opaque object, and you cannot see through an opaque object. So the only thing an opaque object does is that it can only reflect light, okay. Then a white translucent object is that you have light pass through it quite well, but you can't see through it, okay. You can't see through a translucent object. And of course you notice that in some glasses, okay, some car glasses where you cannot see anyone inside the car, but from the other side of the car they can see you, right? From the other side of the inside the car, okay, of course they can see you because light rays from, okay, you as an object passes through it, but you cannot see through it. So please take note of that. We proceed. Now let's look at how we can represent light. All right, there are different ways we can represent light. We can represent light using ray of light, okay. Ray is used to represent light from a very tiny source, okay. Let's say small touch that has small pointer, right, can be represented using ray of light. And of course you have a straight line, okay. Let me use a straight line, okay, something of this nature. There is an arrow showing the direction, right. Then we now have beam of light, right. Now beam of light is made up of two or more rays, okay, and of course it's actually used to represent light from a very large source, okay, for example a searchlight or a torch with a bigger, okay, surface area, okay. So which, if I'm representing beam of light, there are three ways to represent it. It's either the beam is represented as a parallel beam, okay. This is a parallel beam of light. That means the rays in the beam are parallel, right? They are parallel. So I have this. Okay. Or we have what is known as convergent. So this is parallel. Parallel beam. Or you have what is known as convergent beam, where the rays actually meet at a particular point. Alright? They meet at a point. This is convergent. Or you have divergent, okay? Divergent is simply means that from a point they move away from each other. So this is convergent. And of course this is divergent. Alright? So this is how we represent beam of light. Parallel beam, convergent beam, and divergent beams. Okay? So please take note of that as we proceed. Okay, so now this tutorial we are actually looking at reflection, refraction, of course, dispersion. Okay, so we are going to actually go straight to reflection of light. Okay, now what is reflection of light? Now of course light actually reflects, okay, as actually meets an obstacle. So when light is actually being bounced back to the medium, okay, or hits back uh, from where it's coming from, as it meets an obstacle, right, or a boundary, it actually meets a boundary, it's said to be reflected. Okay, so let's say this light, we call the one that hits the boundary the incident, then it moves back as it meets that boundary, that is a reflected ray. Okay, so this is known as the incident, and this is known as the reflected ray. Okay, so now take note of something. Okay, so since I have both the incident and reflected, they hit the surface. Okay, so this is the surface where the reflection actually occurs. I can draw a normal. A normal is just simply a straight line that is drawn. Okay, a straight line that is not inclined at an angle, that is drawn at that point where perpendicular to the surface. Right, this is the surface. The normal is perpendicular, it's not inclined at an angle. Why do I need to draw normal? So that I can measure the angle of incidence. Okay, so this is called the angle of incidence, and this is called the angle of refraction. Okay, so please take note of that. Angle of incidence and angle of refraction. Alright, then of course I0 is equal to the angle of reflection. Okay, so now we will look at the terms. Okay, important terms you need to actually understand when it comes to the reflection of light. Now, before then, okay, let's look at types of uh reflection. Okay, types of reflection. Depending on the surface, on how smooth, okay, or rough the surface is, reflection can actually be classified as either diffused or it can be classified as regular reflection. Now, when do we have diffuse reflection? Okay, we have diffuse reflection when the surface, excuse me, the surface to that actually that the rays of light hit is not smooth. All right, the surface is not smooth. So because the surface is not smooth, all the parallel beam of light that actually hits it as it after reflects, okay, they actually cross each other. They scatter and they cross each other. They are not parallel. Okay, even though the incident beam is parallel. Okay, but the reflected beam is not parallel. Right. So when the reflected beam of light that is incident on the rough surface, okay, crosses each other, such a reflection is known as diffuse reflection. But a regular reflection is actually very smooth type of reflection in that, okay, the parallel beam of light that hits the surface, all right, reflects parallel, okay, without crossing each other. Okay, so this is diffuse and this is regular reflection. Okay, so please take note of that as we proceed. So as we now gonna look at terms, okay, terms that you need to know when it has to do with reflection. So first of all, I draw my surface. I will be illustrating this term one after the other, and of course I'll use diagram. Okay, so you can just be writing it down. Alright, so now one of the terms I will actually talk about is what is known as the one we've actually mentioned. Okay, the angle of incidence. Right, we know this one already. I've talked about this. Okay, the angle of incidence. Right, so the angle of incidence is simply the angle that the incidence ray makes with the normal. This is the normal, right? Normal is a line drawn perpendicular to the surface. Okay, this is the incidence. We know that already. Incidence ray, and of course this is the reflected ray. Reflected. Alright, so the angle that the reflected ray makes with the same normal, okay, but the normal doesn't have arrow, is called the angle of reflection. Alright, now there's an angle here, that is the angle of either the incidence or the normal, okay, mixed with the surface, okay. I call it alpha. The alpha, this angle alpha, is what is known as the glancing angle. So in most cases, as you can see from this diagram, okay, the normal and the mirror they're perpendicular to each other. That means they are 90 degrees. So from here to here is 90, all right? So which simply means that if I should have my glancing angle and I was not given the angle of incidence, all I just simply need to do is to subtract the angle of incidence from 90. Then I have the glancing angle from 90, okay. Let's say a situation where you have something like this, okay. Let's say this is 30, okay. So for you to get this is simply 90 minus 30. So please take note of that. So glancing angle is the angle that the incidence or the reflected ray makes with the surface of reflection. All right. Then of course there's another term I need to actually talk about, that is known as deviation. Okay. Remember, this ray, anytime a ray changes direction, there's always a deviation. Deviation is the angle between the initial direction of a ray and the final direction. Okay, here we go. Now we have something like this. This is incidence on a normal without this boundary, right? Let me okay, so without this boundary, we can simply say that the incident was supposed to move straight, all right, but rather it reflects due to it actually encounters a boundary, right? Incidence, all right, then reflected ray. Alright, so the angle between the incident and reflected ray is what is known as the angle of deviation. So D0 is called the angle of deviation. Okay, so it's the angle between the initial and the final direction of the ray of light. Okay, the initial and the final direction of the ray of light. So I hope that is well understood. So how can I actually get the angle of deviation? Okay, it's just very simple. Okay, if you look at this, the straight line, this angle of incidence is a straight line all the way from here to here is 180 degrees, right? All the way from here to here is 180 degrees. So deviation is part of it. So which simply means that both the incidence and the reflection, okay, is one part of the angle, right? Okay. So the formula for the angle of deviation is simply going to be, for you to find the angle of deviation, okay, that will be 180. 180, then you now subtract the other two angles, which is incidence and angle of incidence plus angle of, okay. Since the laws of reflection, which of course I will state very soon, says that both incidence and reflection, okay, they are the same angle. Both the angle of incidence and reflection, they are equal. Okay, so I can also find the deviation by just using, so that means this can also be, this reflection is also incidence. Okay, so incidence plus incidence, that is 2 incidence, 2I, right? So it's another way of actually finding the deviation of a ray. Okay, so now let's now talk about the laws of reflection. Alright, so number one, Now, number one laws of reflection is there are two laws, okay? Number one states that the incidence, okay, those three incidents, right? Reflected, refracted, reflected ray, incident ray, reflected ray, okay, and normal, and the normal, okay, all this line, incidence, reflected ray, on the normal, they all lie on the same plane. And what is the plane? The plane they lie on is the surface, okay? So please take note. They lie on the same plane. So same plane. They all lie on the same plane. Alright. Number two says that the angle of incidence, okay, is always equal to the angle of reflection. So angle of incidence is always equal to, so please take note. Those are the two, okay, laws of refraction. The angle of incidence is equal to angle of reflection. Incidence ray, reflected ray, okay, and the normal all lie in the same way. So you can actually, I'm trying to detect, right? So write it, make the notes well, write it yourself, right? So now, okay, so we will now look at some typical example that will enable us, okay? There are some parts I'm actually skipping in from this note, so we'll solve some questions. Okay. Okay, so here we go. I'll bring some question now to the screen. Alright, so a ray of light make an angle of 35 degrees with a plane mirror. What is the angle of reflection? So that means from all the indication, what they're asking, this is the ray, this is the mirror, okay? So the ray of light makes an angle of 35, okay? So this ray of light makes an angle of 35 with the plane mirror. So we're looking for what is the angle of reflection. So how do we get the angle of reflection? First of all, we need to get the angle of incidence, okay? If we get the angle of incidence, okay, it is going to be the angle of reflection. So the angle of incidence is going to be equal to 90 minus 35, which is still the same thing. Remember, angle of incidence is also equal to the angle of reflection, right? So this is 55 degrees. And of course, angle of reflection being equal to angle of incidence is also 55 degrees, okay? Okay, that's a question we're going to look at. Let's look at two mirrors that's placed perpendicular to each other. Okay, I have a mirror, a surface, a reflecting surface, alright? One, yeah, okay, so the two surface is being placed perpendicular to each other. So let's say we have this having angle of reflection of, okay, let me just use 30 this time around, 30 degrees, okay, and it is mirror M, and we have a mirror N, and you are being asked what is the angle of reflection of this ray, okay, from at mirror N. Okay, now look at what happens. if this mirror reflects, it will reflect, and of course, and the reflection become an incident to this mirror, right? Then of course this will also reflect. So now how do we get this angle? That is the question, right? Let's see how we do get the angle. Yeah. Okay, so now this angle here is 30 degrees. Okay, if you look at it, this is this will a right angle triangle. This 90 degrees. Okay, and this have actually formed a right angle triangle. The normal, two normal with this angle of reflection forms a right angle triangle. And of course, for me to get this angle of a right angle triangle, that would be 90 minus 30, right? Which gives me 60. So that means the angle of reflection here is 6. Okay, so R2, the angle of reflection in the second mirror end, okay, is 60 degrees. So it just has to do this with angle, okay, especially perpendicular uh, line, okay. You know that for perpendicular line the angle is 90 degrees. Okay, so as simple as that. Okay, so now we are going to be talking about plane mirror, okay, in a moment, but first you need to go through the terms, okay, that we've actually discussed one more time. Then we'll now talk about plane mirror. All right, see you in a moment. Thank you.